Okay, so this video is about structs. I'll just give you an overview of what structs are, what are the different procedures that you can adopt with struct, with structs, and how they are actually used. We'll talk about syntax also. We'll talk about the concepts that are associated with structs. Okay, so structs are primarily user-defined data types. We have already discussed, and you have already you already know about data types that are available with C++, which are default data types, and that include integers, that include float data types, and the other types, and so on and so forth. So today we'll talk about structures that are user defined. That means that you can define a data type of your own that actually combines various other types of data types. So structures or structs, they are used to combine data items of different data types together under a single name. Okay, and I'll just show you an example for that. That how that can be done. I mean, this is just a say a sort of a representation that we have here. The keyword, in order to define a little bit about syntax, a keyword here is struct, followed by the name of the structure that you want, and then within these parentheses you can declare different data types here. Okay, so for example, I can write down here integer x as one data type that belongs to this structure. Then I can have integer y, I can have, let's say, float z, I can also have let's say double here, double v, something like that. So these here, from line number 11 to line number 14, these are all members, data members. We'll call them data members. Okay, so these are data members. Int x is also a data member. Float z is also a data member. Double z is also a data member. Other than data members, you can also have function members or member functions. So for example, I can define a function, let's say print here, and I can write down its type. Okay, and that would be followed by the definition of a struct. Okay, so this here is actually representing what we call as the member functions. So you can have member functions here also. Okay, so we'll have a discussion about how these members are actually declared, how can you retrieve these members, how can you use these members in order to make your program more efficient and more presentable. Okay, for that, let's take an example code here. Okay, and I'll just represent a structure here, which is an employee structure. This contains the three data members here. So these are the data members that are included in this structure: employee, the name of the employee, the age of the employee, and the salary of this employee. So this representation is primarily combining three different types of data types together, and it has got three data members. And together, the name of this struct is employee. Okay, so employee is our structure that we have defined. It's a user-defined data type, and as you can see that it actually combines a lot of different members, data members. It could also contain functions, as I told you earlier. Okay, and in order to initialize these members, you can write down, I mean, this it can be written in your main program, the definition or the declaration of a structure, or the definition of a structure could come before the main program. So we can write down our main program here, and in that main program here, line number 17 is actually representing the initialization of this structure employee. And here you can see that the right hand side we have initialized some of the values. The interesting thing here is that the employee structure or the employee structure struct, we have defined an instance of that. That means that one of the employees, if let's say a company has got 10 different employees or n different employees, then each of that employee can be represented through this structure employee, right? So we'll say that, okay, employee number 1 is one instance of this structure employee, and the name of that employee is Yasir, the age is 32, and the salary is, let's say, 75,000. Again, we can write down the detail of employee number 2 also. Okay, so we can say that, okay, employee number 2, the name of that employee is, let's say, Shahid. The age of that employee is, let's say, 25. The salary of this employee is 25,000. Okay, so these are two instances that have been defined of our structure employee. It's very similar to what we are doing here. Okay, int is a data type and age is an instance of that. Okay, when I say instance, that means that it is one of the variables that have been defined as integer. So similarly, employee 1 is one of the variables or one of the instances of our structure employee that we have defined here. Okay. Similarly, employee 2 is another instance or another variable that has got this property. So it actually gets all these attributes or all these member values. Okay, so if I want to retrieve the information related to employee 1, I can actually use some specific representation in order to get this information about employee 1. Similarly, I can get the information about employee 2 in my main program, and I can use that information if I want. Okay. Structures, as I told you, in terms of the scope, it has actually got a global scope. That means that it's not limited. You can define the structure outside your main program in the declaration domain, or you can define a structure within your main program also. So I can take this part from 9 to 11 and define it within my main program. That will not have any bearing on my program at all. The scope, I mean the accessibility of age and salary and name is global. That means that I can actually approach this value from anywhere from my main program. Okay, so let's take a very simple example and see that how once we define this, how can you retrieve these values. So I'll write down a piece of code here. I've just displayed a piece of code here with employee structure. These are the 3 data members that you have got of the employee structure. Here the initialization has been done, which is on line number 21. The initialization contains employee number 1. Okay, and you can see that I can retrieve the value associated with employee 1 using a special notation which is called the dot notation here. So dot is actually used with the name, the instance name, and the data member. Okay, so employee 1 dot name will retrieve the value of the name that has been stored against employee 1. Similarly, employee 1 dot age will retrieve the value of age stored against employee 1. And similarly, employee 1 dot salary would retrieve the value of the salary that has been stored against employee 1. So employee 1 can be seen as an instance, or it can be seen as a variable that has been defined with against this user defined data structure which is called employee here. Okay. Okay, so let me just run this program. If I run this program, you will see that it perfectly runs and it gives you the values here. So these 3 lines here, line number 21 to 23, they are basically giving you the value. You are retrieving the value against employee 1 all the 3 attributes or the data members of employee, and then you are displaying them. Okay, we have written this keyword struct here. I mean, even if you remove this keyword struct here, even then I think it would work. It will. Let me just run this, and it works. So that means that this keyword struct need not to be written when you are initializing a particular instance of a structure. Okay. Um, so the idea is that when to use a struct, you can use a struct when you want to represent entities in your program that have multiple attributes. For example, an employee in a company has its own name, its own ID representation, its own salary, its own timings, its own qualification, and these are all different data types. Okay, so if you want to represent employee as a whole, then you can define a structure. Similarly, you have a phone book. In a phone book, you have different things. Okay, you have the name of the person, you have the telephone number, you have got the address of that particular person, and these all are of different data types. Okay, so if you want to represent a person whose name is present in a phone book, you can define a structure and then define an instance of that structure to represent a particular person. When you are defining a structure, that means that you are actually defining the structure in which a phone book has been arranged. The important thing here is that this is the syntax that you have to follow in order to generate an employee, in order to generate a new data type, user defined data type, which is a hybrid data type that we call it. And then you have to use this dot notation in order to retrieve that information. And in order to declare an instance of this data structure, you can in this data type, you can write down the name of that structure followed by the name of the instance, right? And then you can initialize all the attributes that you have got here. Okay, so this was simple. Similarly, we can have other examples of structures that you can define. You can also retrieve the information that is present within a structure through uh, pointers. Okay, so pointers can also be used. Okay, because we already know that how to define a pointer. A pointer, generally you have the data type followed by the static symbol followed by the name of the pointer, and then you initialize it. Okay, so initially let's say कि मैं एक pointer define करता हूँ to an integer variable. So if I want to define a pointer to a pointer of integer type, this is what I write: int static, let's say ptr. Okay, and that ends, and then I can actually also write down an instance of this. Let's say instance is g, which is assigned a value of 12, and then I can actually initialize my pointer by using this notation which I've got here. Okay, so it would actually work. So this is how you define a pointer to an integer, a pointer of type integer. Now similarly, because employee is also a data type, but it's a user defined data type, therefore I can also write down a pointer to employee. I can also write down a pointer of type employee. Okay, so I can actually do that, and in order to do that, what I'll have to do is that I'll have to declare a pointer here which is of type employee. And as I told you कि जैसे आपने integer का किया है, तो you can replace this word integer with employee. Okay, and this would generate what? This would generate a pointer that points to a structure employee. Okay, but then in order to initialize this pointer, you will have to point it to some instance of this structure. Okay, so some instance of this structure. So employee 1 is an instance of this structure. So I can actually write down ptr. It points to an instance, an instance of employee. And here employee 1 is an instance of employee, so I can actually write down ampersand followed by employee 1. Okay, and here I've actually initialized it. I'll remove this example. This was just to show you, just to give you a sort of a revision that how the pointers are actually declared. Okay, so this is how you can actually declare a pointer that is actually pointed to an instance of a structure employee. So now PTR points to employee 1 or is being initialized by point 1. And I can retrieve this information and using the pointer. And in order to do that, I can actually okay. So let's just run this for an instance. Let's just run this. So it works. That means that this is perfectly fine. Now, how to retrieve this? How to retrieve? Either you can use dot notation using the instance followed by the name of the attribute, or if you want to retrieve the instance using the pointer, then you can replace the name of the instance with the name of the pointer. In that case, you will not be using this dot notation. In fact, you will actually be using the arrow notation. Okay, so if I use the arrow notation, then that would mean that pointer would now get the value of name, and now pointer, because it's pointing to employee 1, therefore it would get the name of employee 1. So if I run this program, you'll see that the name Yasir still comes out to be. So either you can have a pointer representation in order to retrieve the value that is present in an instance, or you can use the arrow notation with the pointer. Okay, you can also use, let's say you can also use pointers to initialize the value. Okay, so in that case, let me just comment out this part. Here I am just introducing an instance of employee, and then I have written a pointer to employee, and now I can use the arrow notation to assign a value to name. Okay, so I can actually, let's say, write down the name Yasir here. Okay, so if I do this, you will see that if I run this, oh sorry, this would have some error, so let me just rectify this. Okay, let me just run this now. Okay, sorry, that was um, right, G. So we'll be using PTR pointer to retrieve the value here. So let me just rewrite what I was writing here. I'll use the arrow notation PTR to name, followed by, let's say, the name Yasir. Okay, and let me just run this again and see that what happens now. Okay, so now it gives you an error. It says that incompatible type in assignment of constant char to char. Okay. So that is actually an incompatibility. In order to run this, I'll just make a small change. I'll just declare this as a string. And what impact that would have? It would remove this error. Let me just run this again. And now the error has been removed. Okay, so I'll leave this for you to figure out कि दोनों में फ़र्क क्या है. Why char didn't work and the set size didn't work, and why did the string thing actually work. I mean, you can try to find out this answer, and it's not that difficult to figure out that. Okay, and I'll leave that as an exercise for you. So you can see here that okay, you can use this arrow notation in order to even enter the values here. So, and you can see the other two values, they are actually the junk values here. So I can actually use again PTR arrow notation to assign the value to age, and that will be, let's say I can put a value, let's say 30 here, and similarly I can use the pointer notation here to write down the salary of this person, and let me say that the salary of this person is let's say 45,000, and then I can run this program and you will see that okay, it works. Okay, now so the arrow notation is actually used here. The next thing that we'll be discussing here is that you can actually use these structures and pass these structures as arguments to functions. Okay, so for that let me just write down another program here. Okay, so let me just paste this program here, and let me just organize this a little bit so that it's easier to understand. The structure module has been defined here, right? And you can see I've defined a function here which is called the display function at line number 19, and this takes what? The argument of this function is primarily a structure. The argument of this function is primarily a structure here, right? Right. So the argument to this function is a structure, and this function is doing nothing other than that it's displaying some values, the average value and all that, right? So it's actually displaying that value, right? So structure module, an instance of module is taken as an argument here. So here is the main program. We are defining an instance of module structure. Then using the dot notation, we are assigning some values here to the two variables that we have got here, or the data members that we have got here. And then we are calling this function display here, right? So we are calling this function display in order to run this function. Okay, so let's run this. Okay, so the function runs. M1 is an instance of module, and that is passed as an argument to this particular function, right? So structures can actually be used as arguments to functions. Okay, so we have the keyword struct here. Now let me just remove this keyword from here and see that whether it would work or not. Let's just run it and see that whether it works or not. Okay, so it works. So that means that you need not to write struct here. Okay. Even if you write that, that won't have any bearing on the running of this particular program. Okay. Same is the case at line number 26. If you write struct here, it won't have any bearing on that. Okay, so I think you can very easily understand that why structures are used and why structures can be used, and what is the reason of using structures. So I think these very simple examples would tell you that why these structures are important. Okay, and what are the different functionalities that are associated with that. Let me just write down another piece of code and let's see that what's happening in this particular piece of code. Okay, just for understanding, I'll just organize this a little bit so that you can actually see that what's happening in this particular case. Okay, we'll come to this bit here in a while. Right, G. Okay, so again we have a display function in this particular case that has been defined. Right. Okay, so let's just study the first part. So there are two structures that have been defined. One is on line 12 to 13. One structure type has been defined. And there are three data members for this. And all these three data members are integers, average, highest, and lowest. So these are the marks in the assignments. What is the average marks in the assignment? What is the highest marks in the assignment? And what is the what are the lowest marks in this assignment? Okay. And then we define another structure, which is structure module, that is from line number 16 to line number 18, in fact. Okay. So the important thing here is that what we have done here is that structure assignment has become a member of the second structure. Okay, so here what's happening is that assignment is a member function, a member structure of module. Okay, so this is what you call a nested structure. So you have a structure within a structure. So there is another structure that you have got that has become a member of another structure. So assignment is a member of module. And what would that mean? That would mean that you can access the members, the data members, the functions of assignment structure through module. Okay, so you can access average, highest and lowest marks that are part of the assignment structure through the instances of module. That's what it means. So how the procedure would go? The procedure would be such that first of all what you will do is that you will access the members, you will access the member of module. Okay, you will access the members that are present in module, and then through that member you can access the structure members of assignment. So let's say if I declare an instance of module, and then through that instance of module I can access an instance of assignment. Here I have declared an instance of assignment as A. So I can access A through an instance of module, and then through A I can access, because A is part or A is an instance of assignment, therefore I can access the members of assignment through A. And this would use a double dot notation. So just how will you write this? Let's say I've declared a member, I've declared an instance of module. Let's call that member, that instance as M1, and let's suppose कि ये module का एक instance है. And how can I access the members of module by an instance of module? Through a dot notation. So I can access A through a dot notation. लेकिन through A I can then access average, highest and lowest instances. So A dot average. Now this would be the statement that I'll write down in order to access average through an instance of module. Okay, so you will have to have two dots. One dot will access the members of module structure. The second dot would access the members of the assignment structures. Okay, so let me just show you how this will happen. Here is a function, display function. I am displaying the members of assignment through the access of an instance of module structure. Okay, so here is a function. I'll display the name present in module instance. So M1, if M1 is an instance of module, here I can actually, as I told you, इस structure को लिखने की ज़रूरत नहीं है, लेकिन even if you write down, that really doesn't matter. So module M1 is an instance of module. So M1 dot name will retrieve the name, which is a data member of module. M1 dot ID will retrieve the second data member. Okay, M1 dot A dot average will retrieve through M1 average. Okay, so M1 accesses the member of assignment, and then the member of that assignment structure accesses the data members of assignment. So M1 dot A dot average. This is how I'll write down. So I can access all these three different values here. Okay, and this is the display function. As I told you, the function itself takes in structure as an argument. Okay, so here in my main program, I'll declare an instance of module. I can then assign the values using the dot notation, and I can assign the values to the assignment structure by accessing the structure member of my main structure, which is module in this particular case. So m.a.average will assign the values of average to instance A of m1 of m, which I've actually described, and then I can display using the display function. Okay. So the display has actually been run in this particular case on m. So if you run this program, you will see that you will get the average marks. Okay. Now this really doesn't mean कि आप assignment को directly access नहीं कर सकते. Assignment in its own right is a separate structure, but it's also a member of module structure. So let's say कि मैं यहाँ पे before I end this, यहाँ पे I can actually declare an instance of assignment. So I can say, let's say assignments, and I can say my assignment as an instance. I can directly do that, and then I can actually write down this statement. Okay, and then I can also write down the cout statement in order to get this value. Right, I can get this value from here. Right. Okay. So if you run this, it runs and it gives you yeah, so you say 69 and 10 have been actually been written together. So if I write down here, let's say एंड लाइन अगर आप करेंगे तो उससे आपका ये जो मसला है वो आप हल कर सकते हैं. ठीक है. सो यू कैन राइट डाउन दिस न्यू लाइन कमांड. ठीक है. आई कैन एक्चुअली राइट डाउन दिस हियर. डबल आ गया. Sorry. And here again, and then I can say my average marks. My average marks. Okay, so now you will see that it's being represented correctly. Okay, so I hope this nested structure is very clear. So you can have multiple dots in order to access. So this is a sort of a nested structure where you have a structure within another structure. ठीक है. और आप थ्रू द मेन स्ट्रक्चर आप अपने नेस्टेड स्ट्रक्चर को या सब स्ट्रक्चर को जो है ना वो आप एक्सेस कर सकते हैं थ्रू एन इंस्टेंस ऑफ योर मेन स्ट्रक्चर. राइट जी. सो दिस एक्चुअली completes our discussion on structures, but let's just do another example that would explain function members of structures. Okay. So here is another piece of code. यहाँ पे हमने क्या किया है, we have defined a structure point, इसमें data members दो हैं, x and y, and then there is a function. So you have a member function also that is available. So you have a member function. This is what you call as, or you can call it function member function, member function. ठीक है, तो print is a member function of point. So print can be accessed through point. ठीक है, structure. And it's exactly the same way in which any data member or any data member can be accessed. Okay, so you define an instance of point as a, फिर आपने a dot x से आप you can assign that value, a dot y के साथ you can assign a value, a dot print से आप उस function को call कर सकते हैं. You can call that function. ठीक है. And here is the notation which uses a pointer representation in order to access that print function. Now if I run this program, you will see that this program actually works. एक dot notation के साथ और दूसरा pointer notation के साथ. So you can actually see that this can actually be done. Now what if you try to retrieve, what if you try to access x directly? Okay, so if you want to access x directly, will that be possible or not? So let me just write down here, let's say, because x has been defined here, so I can actually say x is equal to 5 or assigned a value of 5. Will that work? Well, you can very easily see that this is not possible. So this was not declared within the scope. So all this x and data members, they are defined within the scope of the structure, so you can't really call them directly. Similarly, you can't call this print function directly. Okay, that print function has to be called through an instance of your structure, not directly. Okay, this should be very clear in your mind. So you can have data members, you can have function members, you can have structure as a member of another structure. All these different things can actually be done. Okay, an important thing here is that there is a special type of a function that becomes a member function of a struct, and that special type of function is what you call as a constructor. What is a constructor? A constructor is primarily used to initialize the data members of a structure. Okay, especially used to initialize the data members of the structure. So let me just remove this bit, all this bit for a while. If I define only an instance of this structure point, right? If I run this program now, this program, okay, runs perfectly. I can use a dot print, in order to see whether this function is called or not. Let me call this function, and you will see that there aren't any values that are present there, x and y. X and y को जो है ना वो आप कर सकते हैं. I mean they haven't been properly initialized in this particular case, and most of the time what happens is that there are some junk values that are stored within x and y. Okay, because if proper initialization is not done in this particular case. Okay, so what I can do is that I can write down a very simple program here which is called a constructor that would always initialize the data members of a structure. Okay, and how that can be done? That can be done through writing a very simple program, and in this particular case this is primarily a program that is called point. Okay, so within the structure, let me write down another function. Okay, and this is what I call as constructor. And what is this constructor doing? This constructor is primarily initializing the data members of the structure point. Now there is one thing that you need to know here, and you need to realize that the name of the structure and the name of the function are exactly the same. Now why exactly the same? That's the question. Let me just initialize it with a different value. Let's say मैं x को 1 से initialize कर देता हूँ और y को 1 से initialize कर देता हूँ. Now if I run this program, you will see an initialization of x and y has taken place. Let's go to our main program. I haven't called this function at all. So how come this function got executed? I haven't really called this function explicitly. A dot point तो मैंने कहीं पे लिखा ही नहीं है. But still, the initialization took place. Right? So what's the reason for that? The reason for that is that this special type of a function, which is called a structure, constructor, and the property of this constructor is that the name of the structure and the name of this function is exactly the same. We'll call it a default constructor. Why default constructor? The default constructor means that this would be called every time whenever an instance of point is declared in my program, and that would be an automatic call. You don't have to do an explicit call for this. So let me just show you that how it actually works. So I'll actually declare another instance of point. Let me call this as point B, and then I'll call this function b.print just to see that what happens. And you see, even in the second case, the initialization has taken place, and the initialization has taken place as 1 and 1 for x and y both. I haven't done an explicit call for A instance of point or for B instance of point. No explicit call at all. It's automatically called. Now that's the advantage of having a constructor. It would automatically, by default, be called and would assign the values which you want to assign or through which you want to initialize the data members of your structure. You don't have to explicitly call them. Even if you forget to assign these values at the first place, the default constructor will make sure, okay, the data members gets initialized, right? So I hope this is clear. Now this is a very important point, and this is a very important concept that has to be taken into consideration. A default constructor, whenever you define a default constructor, it should have the same name as the name of the structure, and you don't have to do an explicit call for a default constructor. Okay. And what is the other thing associated with the default constructor? The other important thing associated with the default constructor is that there isn't any argument list for this. You need not to write any argument list for this. Okay. Even you don't have to write down the return type in this particular case. Okay. It's automatically called, and that's why it's actually called constructor. This is a very, very important concept that you need to know. Okay. So we have discussed about the default constructor. Now here you see that there are two instances of point A and B. These are the two instances. What if I want to initialize B differently? Now at present you can see that both of them have been initialized as 1 and 1. So let me just run this program, and you will see that A has also been initialized. उसके data members भी 1 1 से initialize हो गए, और B के भी data members जो है ना वो 1 1 से initialize हो गए. But what if I want to initialize B differently? मैं b के x और y को मैं इनिशियलाइज करना चाहता हूँ by using the value 2 and 2. So in order to do that, I'll have to declare another type of constructor. This is what you call as parameterized constructor. So parameterized constructor is written in exactly the same form. जिस form में मैंने default constructor लिखा है. The only difference is that now you will be passing some parameters to this constructor. और यहाँ पे I'm passing 2 integer values as argument to this constructor, and now I'm saying that x gets a value a and y gets a value b. And what are these a and b? That I'll define when I define an instance of point. So यहाँ पे 43 line number 43 में I have actually defined an instance of point which is b in order, and if I don't do anything, what will happen here is that the parameterized, the non-parameterized constructor, that means that the point constructor would be called. Let me just run it. So you will see that it gets initialized by 1 1. But if I want b to be initialized using 2 2, I'll just, when I'll initialize it, or when I'll define the instance b, I'll just pass 2 arguments here. Now let me just run this. Here you go. You will see that the second instance, which is b, now x and y of b have been initialized by 2 and 2. So what has happened now? As far as a is concerned, default constructor is automatically called. As far as b is concerned, I have given an explicit call to the parameterized constructor. I don't need to write the name of this constructor because the name of this parameterized constructor is again exactly the same. There is no difference. The only difference between default and parameterized constructor is कि यहाँ पे मैंने कुछ arguments pass किए and I have assigned them to x and y, and those arguments are actually being given here. So when an argument is assigned to an instance, this would call the parameterized constructor automatically. Right? I don't again have to give an explicit call using the function name. Okay? But this is an explicit call to parameterized constructor because I have given some parameters here. You can give a different value here and run it, and you will see that y will get a value 3 and x will get a value 2. This is what you call as parameterized constructor. Right? I hope this concept of constructors is very clear, because this is a thing that you'll actually be using a lot in future, and then we'll discuss classes again. The same concept will be used. Now there is another concept that is associated with these structures, and that would again carry forward when we'll be discussing classes. That is how to limit the scope of the variables that have been defined, or the members that have been defined within a structure. So that's one thing. The second thing is that if there are multiple structures that are defined and you have a nested structure, then the nested structure has its own constructor, and then the main structure also has its own constructor. In that case, what happens? आपके variables जो हैं वो किस तरह से initialize हो सकते हैं? Okay, these are all different things that we'll be discussing in future. So far, I think this is enough. We'll meet again and discuss some advanced concepts related to structures again. And once we are done with structures, we'll move on to the classes. Okay, that's it. Thank you very much for your time. Jazakallah.